So let's start writing the code for quicksort. Let's take array with few elements, and now let's call a method called quicksort, and let's pass the array lower bound, which is 0, and the upper bound, which will be the length minus 1. Let's create this method, and here I and j are lower bound and upper bound respectively, so let's replace them, lower bound and upper bound. Now inside this method, let's take index, where we will store the index of the pivot. So if the lower bound is less than upper bound, then we are going to call the partition method, partition, and we're going to pass the array and the lower bound and upper bound to this partition method. This will give us the index of the current pivot. Let's create this partition method. So here, while let's take pivot, and we are going to take the first element as a pivot each time, so it is the element present at the lower bound. Left is also the first element at the first element, which is the lower bound, and right will be at the upper bound. So we have taken the pivot, which is the element at the first place, and we have taken 2 pointers, left and right. So when the left pointer is smaller than right pointer, we will do some stuff. So here, while left is element at the left is smaller or equal to the pivot, and also if left is within the array bounds, that is, it is less than the array dot length minus 1, that is the last index, then we are going to increment the left pointer. And same if right is greater than the pivot, value at the right is greater than the pivot, and if the right is greater than 0, that is, it falls within the array bounds, then we are going to move towards the left, right? So we will do right minus minus. This is upper bound. So now when left and right pointers are stuck, that means the elements are out of order, so we must swap them. So let's swap them. Let's take a temp variable, and let's put the left element here in this temp, and at the left place, let's put the element present at the right, and at the right place, let's put the element present at the left, which we have in temp. But before doing this, we must check that left is less than right or not. If it is less than right, then we are going to swap these elements. So after doing this whole thing, the current iteration is complete. The last step is to swap the lower bound with the element present at the right index. So let's swap them. So let's again take a temp, and let's put the value present at the lower bound, which is the pivot, and now at lower bound, put the value present at the right pointer, and at the right pointer, put the current pivot, which is present in temp. Now the current pivot comes to right index, so we are going to return this index from here. So after returning this index, this partition method is complete, and now this is the index where we have to perform the partition. So at either side of this index, we will be having 2 subarrays, and again we are going to do this whole stuff with those arrays. So first array starts from lower bound till index minus 1, so passing the index minus 1, and the second array, it is, let's pass array, it starts from index plus 1, goes till upper bound. So this is the complete implementation of quicksort algorithm. Now the last thing we have to do is to print the elements of the sorted array. So let's take a conventional for loop, and here let's print all the elements, all the sorted elements, by writing ARRI, and let's give some space here. So now the implementation is complete. Let's run this program and see the output. So this is the sorted output we are getting after applying this quicksort algorithm. It was very simple